Vaidehi, Hardik, hello, I am audible, no? Hello, hello, am I audible?
Yes, sir.
Now, what I was asking you that this question, have you done this Laplace transform?
No, sir.
Hmm. Have you understood this?
Half of the sum.
Sorry, half of the sum you understood, which you are not,
Yeah.
uh, which you are not understood.
After the separation, I mean the s
After
upon.
this you understood, no? Laplace inverse, that is, you have to check the rules. That is,
Yes, sir.
you have to check this form, you have to compare, and accordingly you have to get the Laplace inverse, and then you have to check particular solution and complementary solution. That is transient response and steady state response. This part is clear, no?
Yes, sir.
And then one part is just to get a partial fractions, you know. So which you are saying after x means what? Where? Which you are talking about?
After partial fraction.
After this is all partial fraction. This is partial. You can see this cursor, my cursor.
Sir.
Uh, Can you just read? The screen is visible, no? Just read it. Or you want me to zoom?
Sir, I haven't tried right now,
Mm-hmm.
but I will try today.
You try this, huh? Whether you also this
Sir,
partial fraction.
I've tried the question and I
Mm.
understood it, sir.
Acha, you got no this partial fraction, etc. These are all maths only, algebra.
Yes, sir. I understood it, the Laplace transforms and partial fraction part also understood.
Okay, good. Okay, then you upload this only this question only. I will upload the question, and then in response to that you can upload your answer. What about the graph? Both of you have not done it.
Sir, I have uploaded it on Sunday only, sir.
Such a graph you have uploaded. Just a
Yes, sir.
minute. Why I could not? Yes, yes. So these are all output graph or what is this?
So these are output graphs.
So you have to write that equation, but I am doubtful about this. This is a straight line only you are getting.
So I'm not getting like straight line, but it is like in the beginning it is slightly curved.
Uh-huh. What? How did you got this? I mean, you have done calculation on the laptop or on the calculator?
So on calculator.
Calculator. ठीक है. कर पे you also try.
Okay, sir.
Okay. So we will go ahead. Laplace, it is around 5 marks. Weightage will be around 5 marks. Okay, so now we know this theta O upon theta I, that is first order transfer function, is given by this relation, that is k upon 1 plus Td. And we know if you solve it, if the input is say h sin omega t, if the input is h sin omega t, then we know we get two responses when you solve the differential equation, that is steady state response and transient, that is your particular solution and complementary solution. Okay. So this is your theta O1, which is given by this relation, that is kh upon root of 1 plus omega square t square into sine of omega t plus phi, where phi is minus tan inverse of omega t, or tan of phi is equal to minus omega t. Now here one part is called as the magnitude, that is b. So if I can replace this b, that is this kh upon 1 plus omega square t square to the power half by b, and this b is called as the magnitude. So we can write this as b theta O1 can be written as b sine of omega t plus phi. So omega is your angular frequency, t is the instantaneous time, and phi is the phase angle. So b is a function of omega. This magnitude is a function of omega. From this relation you can understand. Because k is a gain constant, h is the amplitude, T is the time period, so only variable is omega, that is angular frequency will change from 0 to infinity. Similarly, if you look at this phase angle phi is equal to tan inverse of omega t. So this phi is also a function of omega because t is constant. So we will take omega on the x-axis and b and phi on the y-axis. What we are studying is this frequency response analysis, performance of the system for sinusoidal input. So b and phi, they are function of omega. So you will get two graphs, one b against omega and phi against omega. So in this, you substitute the value of omega from 0 and find out b. Similarly, phi. So if you talk about Cartesian plot of frequency response, there will be two graphs, b against omega and phi against omega. Where b is nothing but this kh upon root of 1 plus omega square t square, and phi is minus tan inverse of omega t, and this is what we have seen earlier in classical method. This solution we can get for the first order system. These are some graphs showing how the roots, that how with the help of the roots we can understand the stability of the system. So if I had told this once, just have a look on this. If the roots are real negative, then the system will become stable after some time. Here this becomes unstable. If the roots are real positive, this is the roots which is shown here. These are negative complex, these are positive complex, and these are only imaginary. So if it is imaginary, if the roots are only imaginary, then it will be marginally stable, that is system is stable by margin. Here it decreases in time and then becomes stable. So there is something called the root stability criteria that we will see later once we complete this plot. Now let us understand how to construct the plot. So this is my first order response. This is input. This B is magnitude, which is given by this kh upon, and this is phase angle. So look at this now properly. Now I want to plot a graph. So what I will have to do, I'll have to substitute I'll have to take the various values. T being constant, I can take the value of omega t. Now here, this k is also constant and h is also constant. So what is done here, d upon kh is equal to this, and b upon kh is written as g. I hope you are understanding this. So for various values of omega t, let's say omega t is 0, you substitute here omega t is 0. So what will be value of g? 1 plus 0, that is 1, square root of 1, that is 1, 1 upon 1, that is 1. Pi, if omega t is 0, tan inverse of 0, tan inverse of 0 will be 0, because tan of 0 is 0. Now substitute omega t as 0.2. Why I am explaining this? Because this forms the basis for your root locus as well as for your Bode plot also further, and Nyquist plot. Now omega t I am taking as 0.2. So this will become 1 plus 0.2, that is 1.2, square root of 1.2. So 1 upon square root of 1.2, that is 0.98. Similarly, phi or phi, tan inverse of tan inverse of 0.2, omega t 0.2, and so on. Now you go on changing the values, omega t, 0.2, 0.4. And lastly, I am varying the values from 0 to infinity. Suppose if I take values of omega t as infinity here, okay. So this becomes infinity, this denominator becomes infinity. So g will be 0, 1 by infinity will be 0. And phi or phi, all these values are in degrees, that will be tan inverse of infinity. So tan inverse of infinity will be 90 degree, and this is minus outside, so minus 90 degree. So now you can plot the graph of omega t. If you plot the graph, then you will get it like this: omega t against g. Omega t you plot here, and g, our maximum value is 1, so this is get 1, and then it goes on reducing to 0 as omega t goes to infinity. अरे रेडी एक हाँ बोलवा देना नहीं तो एक Yes. So when omega t is 0, g will be 1 and then it goes on reducing and finally it becomes 0 as omega t approaches infinity. And now phi t therefore when omega t is 0, initially phi is 0 and then that goes to 90 degree. Now here it is plus, but it will come on opposite side over here. This is not correct. This phi will be like this, minus 90. Now same can be, these two graphs can be drawn by one graph. That is like this. So here, what you do, you draw these lines at various angles. These lines you have to draw at various angles. That is these angles. So minus, this is 0 degree line. And this is minus 11.3. This is minus 21.8. Minus 38.7. And this is minus 90 degree. So these lines are drawn. Then G, you mark G now, 1. So on this line you take this distance as 1. So this is your 1. Then this line you have drawn. So mark, proportionately you mark 0.98. Then here proportionately mark 0.925 like this. I will try to explain. नाही तर ते मागचं प्रत्येक वेळेस हे नका करू. Yes, sorry. Huh? Okay, so now I gave you time because so that you will understand also this. Huh? So this is what is called as the polar plot. Now coming to this. Now suppose if I want to represent this 3 plus I4, this is a complex number. So this is plus 3 and this is imaginary part. So this is point P. Okay. And you have this magnitude, 3 and 4 ka magnitude will be 5. Right? And how to find out this argument or angle? That will be 4 by 3. So tan of 5 will be 4 upon 3. So 5 is equal to tan inverse of 4 by 3. And magnitude will be 5. Okay. So this you are aware in vector algebra. A magnitude root of a square plus b, and phase angle is given by tan inverse of b by a. Okay. Exponential form, see, there are three ways. One is your Cartesian form, then another is your um, polar form, and third is your exponential form. Now we are concerned with the polar form. So I explained you polar form kaise. This. Like now this minus 3 minus I4. So that will come in third quadrant, this point. Minus 3 and minus I4. Again, its magnitude will be 3 and 4, that will be 5. And this angle will be tan inverse of 4 by 3. Okay. Are you understanding or bouncer हो जा रहा है? Hardik,
No,
Madhu?
sir.
हाँ, okay. Now we know this. Huh? Now let us take this example, one example. Now we know this. This is amplitude of the response, that is B is equal to kh upon this, and this is the phase of the response. So phi is for the phase angle, phase of the response. And now this is one example. Here the value of k is, that is gain is given as 3, and h is 2, that is the amplitude. So under root of 1 plus omega t, right? Value of t is also, coincidentally, it is t. Sine of omega t plus 5, and tan inverse of omega t. Value of t is also 2. This is for the first order. So you can calculate now. You go on changing omega, calculate b, calculate phi. Okay. Here it is 0 0.1, 0 0.2, 0 0.3, 1, 2, 3, 4, 5, 10, and infinity. Right? So this graph will be like this. B against omega, and phi, this is the phi against omega. Phi is going now, देखो, it is going 90 degree. And if you want to plot it on a polar plot, so it will be like this. I hope it is clear. And you have to write omega 0. You have to write here omega zero point 0.5, omega 1, omega 10. These are the various angles, 45 degrees, 63, 87. And this is nothing but your value of B is. This is B, this is B, this is B. Okay, like that. This is what is called the polar plot. Why this background is required? Because finally, once you once you draw this plot, then there is one coordinate, that is minus 1 comma 0, that is on negative real axis, minus 1 comma 0. So depending upon the position of that minus 1 comma, now here minus 1 comma 0 is outside this plot. So depending upon the position of the minus 1 comma 0, in whether this coordinate is inside the plot or on the plot or outside the plot, you can directly conclude whether the system is stable, unstable, or marginally stable. So slowly you will understand this. So these are the graphs I said. This is your B against omega. This is your phi against omega. You can practice. And this is your polar plot. Now these are the polar plot. You can get it like this if it is first order system. If it is second order system, polar plot will be like this. If it is third order, then it will end in the second quadrant. I have a lot of sums to practice, don't worry. Here now it is. Look at this example number 3. So this is first order function. Theta is h sine of omega t. So you know this steady state response, kh upon this, right? Now how you have to proceed? You have to write I, you have to write this I omega That is, you have to convert it into complex form. So in place of d you have to write I omega. So 1 plus this becomes 1 upon 1 plus I omega t. So now 1 can be written as 1 plus 0 I, and this is 1 plus I omega t. Now here this is real part and this is imaginary part is not there. And here this is real part and imaginary part is omega t. That means now magnitude. How we can write the magnitude? What is the magnitude of the numerator? Real part square plus imaginary part square, square root. So square root of 1 square plus 0 square. So that is square root of 1, that is equal to 1. Okay. Then denominator में square root of 1 plus real part square plus imaginary part square. So root of 1 plus omega square t square. Okay. So this is your magnitude. And what about phase? Phasor phi will be this minus this. So now what is the phase angle here? What is the argument here? Imaginary part divided by real part. So tan inverse of 0 upon 1. That is nothing but tan inverse of 0. That is nothing but 0. Tan inverse of 0 upon 1, 0. And what about this? This is tan inverse of omega t upon 1. So that is tan inverse of omega t. So what will be the magnitude for this complete system? Phi g is equal to this 1 upon root of 1 plus omega square t square, and phi is equal to minus tan inverse of omega t. Tan inverse of 0 minus tan inverse of, this is omega, this is imaginary part, correct? Omega t upon 1. So tan inverse of omega t. So phi will be minus tan inverse of omega t. Okay, so I have explained you how to get the phase and the magnitude. Now look at this example, example number 4. This is what is the response is given. So theta O upon theta. Now this is in I omega form. So d and d. So 1 plus du replaced by I omega. Du replaced by I omega. Okay. Now here you separate this into real part and imaginary part. Okay, so now here 0.1 into I square omega square. So I square is minus 1. So this will become minus 0.1 omega square. So now what is real part here? 1 minus 0.1 omega square, that is real part. And what is imaginary part? 0.7 I omega. So now we will find out the magnitude P upon Q. ऊपर का magnitude 1 plus 0 I. तो स्क्वायर रूट ऑफ 1 स्क्वायर प्लस 0 स्क्वायर दैट इज 1. अभी नीचे का देखो, रियल पार्ट स्क्वायर प्लस इमेजिनरी पार्ट स्क्वायर. व्हाट इज रियल पार्ट? 1 माइनस 0.1 ओमेगा स्क्वायर, दैट इज दिस, उसका स्क्वायर प्लस इमेजिनरी पार्ट दैट इज 0.7 ओमेगा. Imaginary part is this, no, 0.7 omega उसका square. So this is what is magnitude. Now phase, phi p minus phi q, मतलब this is p upon q फॉर्म. ऊपर हम लोग ऊपर का वेक्टर p, नीचे का वेक्टर q. So इसका क्या आएगा? 1 plus 0 I. So tan inverse of 0, that is 0, minus this is what is the imaginary part? 0.7 omega, real part 1 minus 0.1 omega square. ठीक है, तो ये हो गया. So now concentrate here. Now magnitude is this and your phase is this. Okay. So this is G is equal to this and phase is equal to minus tan inverse of 0.7 omega upon 1 minus 0.1 omega square. ठीक है. Now क्या करने का अभी एक एक वैल्यू चेंज करने का. Omega. This is also function of omega. This also function of G is also function of omega. Phi is also function of omega. So go on changing the values now. Omega 0 से लेके infinity. दो वैल्यूज तो लेना ही है 0 और infinity. And then find out corresponding value of G and corresponding value of phi or plot the graph. Now look at this ये graph. Okay, 1 upon 1 plus t1d 1 plus t2d. So इसको अभी you have to write in p upon q का फॉर्म में. p upon q का फॉर्म में. Just a minute. हेलो हेलो हाँ हाँ बोल. हो हो दादाला बोलला दादा येतोय बरं. मी दादाला बोललो ना ग्रुपवर टाक म्हणून आमच्या आता आमची पूर्ण फॅमिली दादा रिप्रेझेंट करतोय ना. आम्ही काय असे सेपरेट नाही आहे ना एमपीटी. ठीक आहे टाकतो मी. ठीक आहे आमच्या वतीने दादा येतोय आणि दादा जो निर्णय घेईल विराज जो निर्णय घेईल तो मला मान्य. ठीक आहे ओके. हाँ सो नाउ दिस इज पी अपॉन क्यू आर का फॉर्म में. पी अपॉन क्यू आर. So here again this is 1 plus 0 I and this is square root of again T D you have to replace by I omega. D upon replaced by I omega. Okay. So again now G numerator में 1. Here it will be what is your imaginary part here? Omega t1 and real part is 1. So you can find out the magnitude. Similarly now phase phi. You know now this is tan inverse 0 minus. Now what about this? Here imaginary part upon real part. Right? So 0 minus. Now what about this? इसका कितना है? Imaginary part is omega square t1 and this will be omega square t2. Similarly now this directly you can write now phase angle phi is equal to इसका tan inverse 0 minus. Now this is your I omega, correct? So minus tan inverse of omega t1 minus tan inverse of omega t2 and minus tan inverse of omega t3. Now you go on changing the values. Now suppose if I take omega t here, omega t, suppose if I take it as 0. So what will be my phi? Tan inverse of 0 is 0 0 0. बराबर है. If I take it as infinity, so tan inverse of infinity will be 180 or 90. It's 90. Tan inverse of infinity is 90. So minus 90 minus 90 minus 90. So minus 270. So this will be your third order system. So third order system minus 270 from here 1, 2 and 3. It will end up in the second quadrant. Okay. So like that you have to do. Okay. So we'll take few more examples tomorrow, so you will understand it. हाँ, ठीक है. Any doubt so far इसमें जो plot में I hope you may not have understood, but if you practice it, no, one example you will come to know. Tomorrow इस lecture में it will be clear. Anything you want to ask?
Sir, can you upload the video?
Yeah, okay. Yeah, I'll upload.
Thank you, sir.
Or you hold on this, okay? You complete that Laplace transform and the first graph, okay?
Okay, sir.
Wait for one more day, means wait for one more day, wait for tomorrow. So tomorrow it will be more clear, this polar plot. Again, this is for the 10 marks. This is 10 marks plus Bode plot, that is 10 marks. So this weightage will be 20 marks. Our total paper will be of 140 marks, including options, out of which you have to solve 80 marks. Okay, we'll stop here. Thank you.